can assist you or tutor you more. If you have more questions, just email me. The question 64, the third question of the second set of question in chapter 5. Says determine the component's reaction at the fixed support at A. The 400, 500, and 600 newtons forces are parallel to XYZ axis respectively. Knowing that, this problem shouldn't be that hard. It will be a relatively simple question. Now, before we move on to any specifics, we have to figure out what is, what kind of force is being what kind of normal force is being generated at A. Looking at this, it's known that at A there will be a X, Y, Z forces. There will be forces, and as well as moments are being generated at this point. So there are 6 unknowns, right? It's better for us to write it down. So let's say NA, so the normal force at NA in the X direction, NA in the Y direction, and NA at in the Z direction equals all of this, and also the moment, right? The moment at A of X, the moment at A Y, and the moment at A Z, right? And here we go. So we're finding 6 unknowns. Now, don't be discouraged just because there's so many things to figure it out. If we look at, always try to find the sum of the XYZ forces and set them equal to 0 because of equilibrium, and trying to find out as many unknowns as possible, right? So looking at the problem, it's really, they set up really nicely that there's one force in the y direction, net force, right? One force in the y-axis, one force in the x direction, and one force into the z direction, and that is all we have, right? That's the net force. And there's one other forces that's going to each of those directions, and that is at A. So we can just conclude that AX it's literally equals to 400 newtons, right? Because there's only one force going to this direction in the x-axis. There's no other force that will affect that. Since it's in equilibrium, that means there has to be a force going to the x direction with the same amount of force, right? Well, for the rest of it, y is 500 and z is 600, right? You can specify which direction is positive and negative, but we're just going to set all of these are positive right here. And oops. And now we're going to try to calculate the moments, right? Moment at z, it's kind of a common sense because so it says it's 0, right? Give you a heads up. For 500, here's a proof. 500 is acting directly onto the z axis. 400 as well. That means these two forces does not generate any moments on the z direction. 600, yes, maybe, but it's going to the parallel direction of the z-axis, right? If the 500 forces is like over here, then yes, it will generate a force, generate a moment like that around the z-axis, but it's on here and it's on the z-axis, and therefore it doesn't generate any moments. So here's another unknown being solved. Moment of z is 0. Nice. So now we only have 2. That's wonderful. And also, what's really nice is because 2 unknowns, 2 axes of moments that we can draw. That means, when you have 2 unknowns, x numbers of unknowns with x numbers of equations with containing these 2 unknowns, containing these x number of unknowns, you're guaranteed to find the unknowns using matrix or substitution, whatever you're comfortable with, right? So we can just say, to start, let's just say the moment at the x-axis at A. Sorry, I wrote those backwards, but anyway, you get the idea. At A, the x-axis. So 400 obviously won't do anything because it's acting on the x-axis, right? It's parallel to the x-axis, doesn't do anything. But the 500 will. So it's negative 500 Newton times, here it says 1.2, so it's the position of the forces to the x-axis, right? So if you picture this force is over here, then you know the direction from here to here it's 0.5 plus 0.75, and that is 1.25 meters, right? And also minus, here's another force that's generating a moment around the x-axis, and that's 600 from the position to the x-axis. So over here, this area over here, that would be 1 meters. So 600 newtons times 1 meters. And also we have the moment at A. So the moment that's being generated counter to the forces that are being generated at this position A. So plus moment at A. And the reason we say these and these are negative is because if we're looking using our eyeballs over here, right, looking from the x-axis, this is generating a circle around the x-axis, right? So this is the center, there's a circle over here. If we're looking using our eyeballs, look from the x-axis, it's generating a clockwise rotation, right? A clockwise rotation is positive, is negative. Usually that's what we say, right? Because we when we measure angle, we measure from the x-axis counterclockwise, right? And this force as well is going downwards and is making a huge circle around the x-axis. So these are two clockwise direction, therefore we say it's negative. And since there are two negatives, then this must be a positive, right? To set them is equilibrium. So using calculators, calculate these and move them to the right side of the equation, since, well, this thing equal to 0, so you can set 0 over here. So MA would just equal to these whole thing, right? MA, and you plug that into your calculator, it should gives you 1,225 Newton meters, right? That is your MA. So let's write it back over here. 2.23 kilo Newton meters, right? 3 suffix. And now we move on to moment around the y-axis, right? Using the y-axis, let's look at now. We can use the 400 newtons. 400 newtons is generating a rotation around the y-axis, and as you can tell, right, it's moving this way, so that's using your eyeballs over here, right? Looking at it that way, then this is generating a positive, clockwise rotation. So will be this force as well. So 600 and the 400 in this case will generate a clockwise rotation. That means it's negative, right? So 400, negative 400 times the distance from here to the y-axis, the position of the force to the axis, that is 0.75 meters, right? Also minus the 600 newtons, right? Generating a force this way, that's negative. And from here to here, that is from here to here, which is the same distance as this one, which is 1.25 meters, and plus m in the y direction, right? It's positive because these two are negative, and set this is equilibrium, it has to be 0, so therefore moment on the y-axis from the point A should be positive. So moving all of this big chunk of numbers to the left side, anyway, this equal to 0 as well, right? Set this to this side, so and moment on the y-axis should give you, if you plug everything into a calculator, should gives you 750 Newton Newton meters, right? Moment. So should give you 750 Newton meters, and that's it, right? You can highlight your question, but this is well organized, so we can leave it like that. So yeah, hopefully this video was able to help you to understand. This is relatively an easier questions. I think question 65 we'll be using cross product and finding moments in 3D, and that should be more fun. So yeah, hopefully stay tuned. I'll see you in my future videos. Bye. If you have more questions, specific questions you would like me to do, please comment in the comment section down below.